to pediatrics. With over 80 publications to her name, Dr. Zahid has made substantial contributions to her field. Over to you.
Thank you so much, Sherwa, for that kind introduction. Assalamu alaikum and very good afternoon to everyone. I hope all of you are doing good and you are sitting with a fresh mind, because statistics can become sometimes a bit tricky. So I'll share my slides. So today I'll be just introducing you to statistics, what it is, what are variables, and we are going to do some hands-on SPSS exercises as well. I have nothing to disclose. So first of all, when we talk about data, when we talk about statistics, basically when we talk about data, the major important thing when you have the data with yourself is how to organize and how to display the data. So that is important, to our mind now. Data is there, what to do with it. So first of all, what is statistics? Statistics is just the science of data, of collection, organization, summarizing, analyzing, interpreting, presenting, and ultimately drawing conclusions from your data. Now, if we talk about biological or medical sciences, so the data that is related to any biological or medical sciences, that is known as biostatistics. So when we talk about data collection or extrapolating results to the population, so when you're doing research, it is not possible to go out in the field and take everyone's data, right? So ultimately our goal is to take the informations coming out from that population on which you want to extrapolate, or in other words, generalize your results to, right? So when we take the set of measurement which is of interest to the investigator, like, for example, if you want to inquire about the household income in Pakistan, so that is, that will be known as a population, right? However, if you are going to just survey 1,000 households income, from all parts of Pakistan, that will be your sample. So, when we talk about census, yes, in census, usually, we are taking the population data. But when we talk about research studies, generally it is not possible, because there are different reasons for this. It can be the cost, it can be the time. So you need to have measurements from the selected population that you want to extrapolate your results on. For example, if I want to maybe, assess the household monthly income of people maybe with a particular type of with a particular group of people, I want to inquire their monthly household income. So it will not be possible for me to go out in the field and take information from all the people. So instead of that, I will take in people, a sample of people from that population, and then do the measurements. So when we talk about statistics, there are basically two types. One type of data that we usually present is this descriptive data, and one is the inferential. So today, we'll be more talking about descriptive data and how to display the descriptive data. And then when we talk about inferential, so inferential is that to draw conclusion on the the descriptive data that you have collected. And then inferential statistic, it is subdivided into estimation and hypothesis testing. That is, if your objective of your study is just to estimate a certain information from your population, for example, just knowing the prevalence of maybe brain tumor, that will be just estimation. However, if you want to draw some hypothesis, that is, you want to see that what are the factors that can be associated with brain tumors, or the factors that is leading to brain tumors. So that will be, so you will be having some hypothesis on the basis of which you would want to sort of assess this objective, right? So this part we are going to do in our upcoming sessions to the descriptive statistics. So before we go and jump on to the SPSS, you need to understand what exactly is a variable and what is a data, right? So, in observing, the various phenomena, we are usually interested in in obtaining observation on specific characteristics. So whenever you have a study question and you plan to do a research, the first important thing that the investigator is expected is that the investigator should know what will be the exact outcome of the research that you want to look at, and what are the variables of interest, or what are, in other words, the characteristic that you would want to exactly look into in a certain sample, right? So that is actually known as variables. For example, if you want to assess the marital status, the socioeconomic status, or any other variables or any other characteristic of a sample that you want to assess, that's known as a variable. While when you talk about the data is actually the observations that you're recording for these variables, which means that each and every patient, which means that if you are assessing the weight of a patient, so that is a particular observation, right? So that is a data. So data is actually the raw material of the statistics, and it can be derived from various sources, right? So you can collect your data, that is, you can collect the information of individuals from various sources. They can be either through surveys. It depends what what you exactly want to do, what is your research question. It can be in form of surveys, it can be in form of experiments, and the sources can be the sources of collection, registries, it can be hospital records, it can be from communities. You're going to the community and collecting information of the individuals from there. So the sources of data can vary depending on your research question, but the important thing is that the source from where you're collecting the data, it should be a reliable source. That's very important. So when we talk about data, so data, it can be actually, and it's basically majorly divided into two, right? It can be either qualitative or it can be quantitative. So you must have heard, when, especially if any one of you are involved in your in research, or even in your synopsis and dissertation writing, that in plan of analysis you have to mention that whether your variable is a qualitative or a quantitative. So this is very important. Again, before you start a research, how will you assess or report your variables of interest, right? So the data can be either quantitative, which means numbers, or it can be qualitative, which means categorical, right? So your variables can be either categorical or they can be numbers, that is numeric. And then further, the quantitative data is divided into ratio and intervals. And we are going to talk about this in my other upcoming slides. And then when we talk about qualitative data, the qualitative data it can be either nominal or it can be ordinal. So when we talk about quantitative variables, as I mentioned earlier, that qualitative variables are variables that have categories, right? For example, if you are looking at gender, so male, female, is a qualitative variable. About household monthly income, that again, it can be a qualitative variable, because again, it has categories: low, middle, and high, right? When we talk about quantitative variables are variables that are numbers. So they do not have any categories. And the simplest example, which is usually used, is age, weight, height. These are all quantitative variables. But there's no hard and fast rules. Sometimes these variables can also be categorized depending if there are established cutoffs for these variables. But generally, when we are collecting the data, and this is actually sort of a very important tip for all of you, that whenever you are collecting the data, always try to collect the data as raw as possible. If you know that age is a variable that you can get raw data, I mean you can get the exact ages of the participants as a raw data, rather than categorizing it prior. Because if you will categorize it prior, maybe while you start data collection, you might want to use the raw information. So always try to collect the information as raw as possible. And the same is for household monthly income. Try to collect the exact income reported by the patients or by the participants, and later on, while you're analyzing the data, they can be categorized. But few variables like gender, marital status, these are variables that are categorical, so you can collect them as a categorical variable. So when we talk about the quantitative data, again, I told you in my previous slide that it can be either nominal or ordinal. So as the name, if you look at the name ordinal, it basically that has an order, right? So for example, socioeconomic status. So there's an order: low, middle, and high, right? Or when we talk about maybe physical activity status, so there's an order, like if you have categorized it into mostly sitting, moderately sitting, or all the time sitting, so that again has a category, so that has an order. So anything that has an order, I mean, if a categorical variable has an order, that is an ordinal data. However, if there is no order, like if we talk about gender, it's just male, females, or if it's maybe a telephone number or a driving license number, it does not have any order, right? It is a categorical variable. And one more thing, if there's any variable that has both in them, like for example, maybe a zip code or maybe a driving license, so that will also fall under qualitative data, but that will be a nominal data because it doesn't have any order. So what we need to remember, any data that has an order, it is known as an ordinal data, that is categorical data, and or qualitative data. And if anything that does not have an order, it is known as a nominal data. Then when we talk about a quantitative data, as I mentioned earlier, there is an interval scale data and then there's a ratio scale data. So what is an interval scale data? So interval scale data, it has a zero, if any variable, a quantitative variable which has a zero, but that zero is an arbitrary zero. For example, if we talk about 0 degrees centigrade temperature, that zero. It does have a value, but it is an arbitrary zero, right? So that is interval scale data. So any quantitative data which has an arbitrary 0 point, it is known as interval scale data. While when we talk about the ratio scale data, so variables in which, of course, 0 has a value, and so that 0 means a 0. I mean, 0 is a 0. So that is actually known as a ratio scale data. For example, when we talk about weight, height, age, these all fall in ratio scale. Then these further are divided into discrete and continuous. So anything that does not have a decimal point in them, right? So it is a whole number that's there. That sort of a data is known as discrete data. And for example, number of siblings, number of visits to the doctor, these are all, they all fall, right? And when we talk about continuous data, it is any data which has decimal point. It can be, age has a decimal point, weight, height, BMI, they all have decimal points, right? So they are all quantitative data. Quantitative has interval or ratio scale, and which are further divided into discrete and continuous. So any questions up till now?
Yes, Dr. Nida, we have 2 questions on our group chat. Would you like to take them now?
Yeah. So is binary data also a subcategory of ordinal data? So see, binary data, like, when we say smoking, yes and no, right? Or we say any data, like, which is a yes and no, or maybe comorbid conditions, yes and no. So that is a categorical data, but it is a nominal data because it does not have any order. It's just, I hope I've answered your question, Maria. Okay, and Isha has asked, okay, as Isha has asked, it doesn't have an order, won't it be? Yes, so Isha is right. So any binary data, which is just a yes and a no, it will be a nominal data. Okay, so summarizing the data. So now, right now, when we were so organizing data, when we spoke about the organization of data, first we need to understand that whether our data is qualitative, quantitative, whether it is a nominal data, it is an ordinal data, and if it's quantitative, whether it's an interval scale data or a ratio scale data, and then further whether it's discrete and continuous. So first you need to be sure about all these things, right? Now you have organized your data, you have that so in organization, once you start analyzing your data, you should actually know whether you are going to treat this particular variable as a continuous variable, or would you want to treat it as a categorical variable. So as I earlier mentioned, like, BMI, it has established categories. So it's better to actually report, such variables which has established categories as a categorical variable. So all this information, it needs to be organized, and then you start summarizing your data, right? So when we talk about quantitative variables specifically, how to summarize the information, right? So there are two things that I'll be talking about today, and we'll be also doing a hands-on SPSS exercise, is the measures of central tendency and variability. So this is how we summarize our data. So first of all, what is a measure of central tendency? So given a data set, a measure of central tendency is what? It is a value around which it is centered, right? So there are three most important types of central tendency, and I'm sure maybe in your O levels or in your A levels metric inter, you must have come across these measures. That is mean, median, and mode, right? So these are the three commonly used measures of central tendency that are used for summarizing your quantitative data. So I'm not going to go into a lot of what exactly the formula and everything is, but I'm sure you understand what is a mean. Anyone wants to tell me, what do you understand by mean? Anyone? Anything. I mean, anything you remember. I'm sure you must have come across, even in your daily life, you come across the averages and everything. So it's simply the sum of values upon the number of values. That's computed by summing all the observation in the sample, as mentioned by Moise, and then you divide the sum by the number of the observations, right? So suppose you have age of maybe 5 patients, or maybe 20, or maybe 100 patients, right? You are going to add in the ages of all the participants, and then you're going to divide it by the number of participants, right? So that is what is known as mean. So it's actually what the average of whatever the outcome you're looking at, right? Then we go to the median. Median, anyone wants to comment on median? Yes, so it's a central value in a data set. So yes, absolutely, you're right, Maurice. So it is actually defined as a middle value, lowest to highest. Yeah, this is actually the catch over here, that you need to arrange from lowest to highest. But see, the good thing is now you have software, so you do not need to do all these things with hand. This can be done manually. It's not required, right? And then when we talk about mode, what is a mode? Anyone? Excellent. So it is the most frequently occurring value, right? So maybe when your data comes regarding certain tumor histopathology, and you want to exactly know that which which histopathology is the most commonly found in these patients. So maybe mode can be very helpful in that, right? Yeah. Thank you, Akif. You're absolutely right. So now the question arises that which tendency should we use, right? So generally, mean is one of the most commonly used, right? Because it is using all the information in the sample, and it is a very good measure only when your data is normally distributed. That is, it is symmetrical, right? And now, I will, so we'll go through SPSS, and, I'll let you know how to know whether your data is normally distributed or not, right? However, if your data is skewed, so what is the meaning of skewed? I mean, if there are any values that are either pulling your data towards the, there's certain observations that are known as outliers, right? So there are outliers that are there, like for example, if there is an average, the patients presenting to your clinic, if they're ranging between 20 and 40, right? So your observations are between 20 to 40. So the possibility is that your data will be normally distributed. How patients who are presenting, they are 70-year-old, or maybe a patient is presenting who is 5-year-old, right? So, and there are very few patients, like that. So in that case, what happens is your data will be either skewed towards the right side or towards the left side, right? In that case, what happens is that if you try to, so this means your data is not normally distributed. Normally distributed data, and then I'm going to tell you what is an empirical rule, which actually will tell you that what exactly is a normally distributed data, right? So whenever your data is normally distributed, mean is the best measure of central tendency, right? But when your data is not normally distributed, in that case, if you try to put in mean, your mean will be either inflated or it will be actually underestimated, right? Because what happens is that mean does not, because of the extreme value, the means it's pulled. So in that case, the best measure of central tendency is the median, right? Because median, it is resistant to extreme observations, right? And the mode is commonly used as a measure of popularity, right? For I just spoke about type of histopathology. You just want to know which is the most commonly occurring. Or maybe, which are they, like, for example, if you want to see which are the preferred painkillers, by the patients, so you can report a mode for it. So this was central of tendency. So this is how the data is, right? Measured when you talk about central tendency. So if your data is normally distributed, your mean, median, and mode, they will be very close to one another, right? So this is actually one way of of when you are sort of eyeballing, or maybe one way of when you're trying to when you're trying to see whether your data is normally distributed or not. So this is one way of assessing it. That is, you look at the mean, median, and mode. If they're very close to one another, this means that your data is symmetric, it is not skewed, and you can go ahead with reporting means, right? However, and this is just one way. When we are going to come on statistics, I'm going to tell you different ways, especially through the statistical software, how to assess the normality of the data. But when we see that our mean, median, and mode, they are very different. There is a difference in them. So this means our data is not normally distributed. So it can be either positively skewed, which means that your data is being pulled towards the right side. This means your observation, maybe they are going higher, as compared to the normal data that is there. Skew, that is, as I said, maybe there's a 2 or 3 or 5-year-old child who is coming for the treatment, while the remaining are between 20 to 40. So your data will be pulled towards the left side, right? So you can see that over here, your means will be sort of overestimated. Over here, it may be underestimated. So you really need to be very careful And one thing I tell you that when you submit it to the journal, so that also I'm going to tell you a trick. How will you come to know while you're reading papers that whether this investigator, assessed the normality or not? It's very easy, right? So this is what is the measure of central tendency. This is how you summarize data, and these are the measure of central tendency. Now, when we talk about central tendency, with that comes variability as well, right? So a data set or distribution with a greater spread, right? And the two most commonly used, three most commonly used measures of variation or dispersion are either range, or standard deviation, and the variance. So these are the three most commonly used. And standard deviation, variation, they are related to one another because the square root of a variance is a standard deviation, right? So range, what is a range? Anyone wants to, tell me what is a range? So suppose there's age and then there's a range that's given with it. What's a range? Anyone? Excellent. So it's the difference between minimum and maximum value, right? And but the range is quick to compute, but it usually fails to be very useful since it only reports extreme values, minimum and maximum. It does not take into consideration the bulk of the observation that are there, right? So we just know that, okay, in our group of patients, there was a patient who presented with, who was 5-year-old, that will be the minimum age, and maximum age was 70, so that will be the maximum age. We do not know what's happening in between, right? But so therefore, a lot of people avoid using range, right? Variance and standard deviation, they are commonly used measure of dispersion. I think I forgot to mention one more, that's interquartile range. So interquartile range is also very commonly used sort of measure of dispersion. It is, we take the 25th, so when the data is there, we see how many observation are there within the 25th percentile and how many observation are there within the 75th percentile, right? And then we report that, and that I'll show you how to report it, how to, assess it, and when to report it, right? When you talk about variance, it's a measure of spread. That is how much your measurements are away from the mean. That is each number of each. Let's, first, if I'm talking about the patient, so if we have 100 patients and we have a mean age, suppose the mean age has come up to maybe 50, right? Just an arbitrary value. So how much is each observation far from this mean? That is actually known as your variance, right? So how much away is your each number is away from the means of that particular data, that is known as variance. And when we talk about standard deviation, that is just a square root of, that's just a square. Sorry, it's not a square, it's a square of variance, right? Talk about normally distributed data, you must have come across this term bell-shaped distribution, right? Or we can also say symmetric bell-shaped distribution. So what is this bell-shaped distribution? So when we talk about the normality of the data, it is the empirical rule. It actually states this symmetric bell-shaped distribution. And according to this empirical rule, 99% of our data should be falling within the 3 standard deviation. So as per the empirical rule, about 68% of the data, it falls within 1 standard deviation, right? About 95% of your data falls within 2 standard deviation, and about 99% of your data falls within falls between 90 and about 99% of your data falls within 3 standard deviation. So if your the 3 standard deviation, it means your data is not normally distributed. It means that the variation in your observations is huge, right? The dispersion is huge. In that case, if there's a lot of dispersion, if there's a lot of variation, this means your data is not normally distributed. And in this case, you will not be able to use standard deviation. You will not be able to report standard deviation and means, right? So when your data is normally distributed data, you report means and standard deviation or variance you can report. That's up to you. But the commonly used is the standard deviation. But when your data is not normally distributed, right? So your empirical rule is not fulfilled. It's not a bell-shaped curve, right? So in that case, your data is not symmetrical. And therefore, you will not be reporting medians. You will not be reporting standard deviation. Instead, you will be reporting what? Medians. You can report interquartile range. So as I mentioned earlier, interquartile range, it actually takes into account that how many observations are falling within 25th percentile, and then it gives you a range that is observation between 25th and 75th percentile, right? So for a typical data set, as I mentioned earlier, it is unusual for a score to differ from means by more than 2 or 3 standard deviations. So percentiles is actually, so if I talk about percentile, percentile is that all the observation, if I say, that if I say about 25th percentile, this means that the observations, or maybe when we come to SPSS, I'm going to explain you that what exactly is a percentile. So now I would like all of you to go to your to open your exercises. And someone has mentioned about interquartile. How do we spell? So NTERQUAR and TILE, right? So it's interquartile range. So all of you, I want you all to open your exercises and just have a look at it quickly. Just, I'll give you 1 minute. Just read it, and then we will come on the SPSS.
Dr. Nida, can we have one question from Farah? I think that was lost.
Yeah.
She asked, when can we use the trimmed mean?
What's that?
Trimmed.
Can she write it down in the chat?
Farah, can you ask again?
Trimmed. Okay. Yeah. So Farah, by trimmed mean, it is actually, when you know that there are outliers are there, right? You can see that there's a large value and then there's a small value. So what you can do is that you can remove those values. So this is one way that you can just remove those observations, those outliers, and the means that you report, they are known as a trim mean. So this is also one way. But see, again, it depends actually that that do you really, if there are a lot of outliers, do you want to remove them or you want to keep them and you want to report medians? Because when you are going to remove the outlier, it means that maybe you are going to remove the whole observation. You'll be removing the whole patient, right? So sometimes it can get a bit tricky, especially if your sample size is small. You wouldn't want to remove the whole observation. Keeping that variable there, in your data set, you might want to report medians. However, if you want to go with the trimmed mean, in that case, what you can do is you can just remove your outliers and then you can report the mean, right? Okay, Sidra is saying, could you repeat what do we use instead of mean when we don't? So instead of mean, when you do not have a normally distributed data, you report median with IQR, right? So, okay. So now all of you, I want to request all of you to quickly just go through the exercise question and then we will talk about it. And you're done, so please just let me know.
Dr. Nida, they were shared the exercises and the data sets, so you may begin.
Okay, that's great. Okay, so I will open. Let me just quickly open the exercise. Okay, so I think there are a few questions, and now I want you guys to answer these questions, right? So there's an opinion poll was conducted about health policies of the government in Health Mela held at Aachen University. The data is given below. So these are the variables that are there: age, gender, socioeconomic status, education. Then the details are given over here about it: opinion scale, and then read newspaper or not, right? So these are the categories that are mentioned. These are the codes that are mentioned. And this is how the codes have been entered in the SPSS software, right? So the first question is, can any one of you tell me age? What type of variable is it? Quantitative, okay. And ratio or interval? Continuous, okay, that's a ratio scale. Excellent. Then what about gender? Qualitative, okay. And is it nominal or ordinal data? Dichotomous, nominal, excellent. Socioeconomic status? Okay. Socioeconomic status? Okay, so some people are saying nominal, and what makes you say that it's a nominal data? So it's an ordinal data because it has an order: low, middle, and high, right? Educational status, opinion, reading newspaper. Can anyone suggest? Okay, level of education on opinion scale. Okay, ordinal, excellent. Yes and no? Excellent, nominal. So all of you are clear with this, right? So first important thing that we need to do is that, so today we spoke more about, because, I had limited time, we spoke more about the quantitative data, but while we are analyzing, I will also show that how do we report the qualitative data. So, qualitative data is usually reported as frequency or percentages. So I'm going to show you that even. So let me go to the SPSS data. So I hope all of you can see this. Okay. So first of all, let's start with age, right? So when I was talking about the normality of the data, if you remember, that was the first thing that I spoke about, that whenever we analyzing a quantitative data, the first thing is to check the normality of the data, right? So we will go to, just hang on, let me just remove this. Okay, so first we go to, Rua, can you guide me how to remove this thing that's coming up? This Zoom ka jo aa raha hota hai, the chat, news chair, and this and that. I just want to remove this because I can't click on those things then.
I think we'll have to. You have all the controls. Yes, Dr. Nida?
Yeah, I do have. How should I remove this? This ऊपर जो चीज आ रही है.
The chat box?
Okay, fine. No, it's fine. Okay, so what you do is you go to analyze, you go to descriptives, you go to so now we are analyzing our age, right? To see whether it's normally distributed or not, and whether we should report mean, standard deviation, or whether we should report median and IQRs with it. So we go to explore, right? Now, age is the only quantitative variable we have. So we are going to put it in the dependent list, right? Then you go to, so in display, it says both statistics or plots. You are going to keep this option of both, checked, right? Then we go to plots, and over here you can see, so as I mentioned, that there are different ways of assessing the normality. It can be through a histogram. It can be looking at the means, median, and the mode. And the last thing is, then there is a test, the statistical test that can be applied, which is either a Kolmogorov or a Shapiro-Wilk test, right? So what we do is we are going to, so the information that is required over here is a histogram, normality, plots, with test. So these are the two things that you're going to check on, right? Then we go to continue, and we go to OK. All right, so let me just stop sharing this. One more thing I think we can do is we can also click on the descriptive. So descriptive, so this, when you, so you also want to know the descriptive of the particular variable, like you would want to know what's the mean age, what's the median, what's the mode, what is the standard deviation. So by default, when you go to statistics, this option of descriptive is clicked. So you don't need to worry, you can just go ahead with it, right? You go to OK, and I'm going to share the output because this is the issue with online that, okay. So you see, this is the descriptive table. So this descriptive table is showing you that age, the mean was this much is the so confidence interval, maybe we can talk about in our upcoming sessions. Then, so as you know, someone spoke about this trimmed mean, right? So in this, what have they done? They have removed, if there was any outlier, they have removed that, right? Then there's a median is there, and then we can see, so these are relevant to us. Standard deviation is there, variance is there, range, that is minimum, maximum values are there, range is there, interquartile range is there, right? So these are all what? These are the descriptives that are reported in this table. So now one thing that you can do is that when you want to assess the normality, you can see mean, median, and where is the mode? I can't see the mode. But mean and medians, they seem to be, do you think they're close to each other or they are away from each other? They are very different. क्या लग रहा है आपको difference ज़्यादा है इनमें या they're close? Okay. Okay. Now, second thing what we'll see is we are going to see this. This is the histogram. Now, looking at, so this is very much eyeballing, right? Eyeballing से आप देखते हैं कि ये data normally distributed है या नहीं है. So by looking at this, what do you guys feel? Is it normally distributed? Like, does it look like a bell-shaped curve or does it look skewed? Almost. So you feel that it is almost normally distributed, right? It looks like a bell-shaped curve, right? Skewed lag raha aapko. Okay. So this is a problem with eyeballing, right? People can have their own, visual wo ho sakta hai. So what we do is, this is the ultimate test that we look at, right? So this is the Kolmogorov and the Shapiro-Wilk test, right? So you can use either of them. Both of them are used for checking the normality, statistical normality, right? So this is what the value you're going to look at. That is the significance, the p-value. So what happens is that p-value, when we look at the p-value, so when we talk about hypothesis of these particular tests, so according to the hypothesis, and again, in my next sessions, I'm going to talk in detail about the hypothesis, but what you need to understand right now is that if this p-value is more than 0.05, right, of any one of these tests, it means that your data is normally distributed, right? So whenever so this is a test for normality. Whenever the p-value of your Kolmogorov or your Shapiro-Wilk test is more than 0.05, it means that your data is normally distributed. So if your data is normally distributed, which measure of central tendency and variation means, and along with means, you're going to report what? Excellent. With means, you're going to report what? Standard deviation. That's excellent, right? So whenever you see that your test of normality, that is your Shapiro-Wilk or your Kolmogorov test, p-value is more than 0.05, it means that your data is normally distributed. It means that that's a symmetrical bell-shaped curve will come when you are going to assess it, right? So this means in this case, means and standard deviation are the appropriate central of tendency, measure of central tendency and variation or dispersion that you can report, right? So now what we will do is, so now we can safely either you can take means from here and standard deviation, or what you can, you go over here, you go to analyze, you go to your descriptives, right? You go to you go over here, frequencies, right? You put your age in this variables list, right? Over here, because this is a quantitative data, therefore you will not report any frequency tables. You are just going to go straight to your statistics. And over here, you can see these options, central tendency. So what you're interested at this point is means. And what you're interested at this point in dispersion is standard deviation, right? So you go to continue and then you do OK, right? And over here, you can see, what can you see? You can see that for age, the mean age is 45.9 and the standard deviation is 12.96, right? So this is how you are going to report and you're going to assess a normally distributed quantitative data. So first of all, what will you do? I'll just quickly tell you, you are going to go to descriptives. So first of all, when you see that, so someone is asking some questions, Dr. Ida, can you please repeat for the test? Okay, I'll do that. So, and could you please repeat the p-value? Okay. So what we do, we go to analyze, we go to descriptives, we go to explore, right? And then over here, you put what? The quantitative variable. That was, over here, age was there. You put it in the dependent list. You go to plots, right? Plots you will be interested in histogram and you will be interested in normality plots with test. So what is normality plots with test? It's the Kolmogorov and the Shapiro test, right? Then you go to continue and you do OK, right? We will then get this, right? So first thing, you can have a look at the histogram, but again, this is really eyeballing. So maybe you cannot draw exact conclusion, but still you come to know, whether your data is normally distributed or not. And you are going to look at this. This is the most important. That is test of normality. That is either you can use a Kolmogorov test or a Shapiro test. So how to assess by the p-values of these two tests, whether your data is normally distributed or not? You are going to see whether the p-value is more than 0.05 or so 0.05 is again, it's the we compare. Actually, I don't want to go into that right now because these p-value level of significance that will be coming in our upcoming sessions, right? So right now you just understand that when the p-value, it should be less than 0.05 or for a hypothesis to be significant, right? For a variable to be significant. So in this case, what we can see is that the p-value is more than 0.05. So in other words, it's more than 5%, right? So right now, for the timing, just keep in mind that your p-value for something to be significant, it should be 0.05, less than 0.05. But in our case, actually, over here, so I'll just quickly tell you that the null hypothesis over here is that the data is not normally distributed, and our alternate is that the data is not normally distributed, right? So when a p-value is more than 0.05, it means that your data is normally distributed, right? So just keep in mind that the p-value, if it's more than 0.05, it means your data is normally distributed and you can safely report means and standard deviation. So one thing that I mentioned that from someone's data that they have checked the normality or not, or whether their data is normally distributed or not, is that if the standard deviation, its value is more than the means, right? So this is one trick for you to understand if you get the paper for peer review, that whether they have checked their normality and whether this is actually the appropriate measure of central tendency and variation. You look at the means and standard deviation. If the standard deviation is more than the means, it means that the data is not normally distributed, right? So in that case, definitely they have not measured or they've not assessed the normality of the data. But whenever we are talking about a quantitative data, the most important thing is that you have to assess the normality of the data, because further, when we talk about different inferential statistics, it all relies on this normality of the data. And if you haven't assessed it at this point, it's a disaster afterwards, because if the journal picks it up, analyze the data again, right? So it is at this point you need to understand that when your data is quantitative, you have to assess the normality first, and then you will decide whether you're going to report means and standard deviation, or you're going to report the median and IQR. So I'm going to quickly show you that where to go and what are the options for median and IQR. So it's similar like means. You go to analyze descriptive frequencies. And over here in statistics, you check on medians. You can check on mode as well. You can check on the quartiles. Quartiles, so as I mentioned, interquartile range. That is, your observation that are lying within the 25th percentile and between the 75th percentile. So because your median is what? Median is for your data that is lying within the 50th percentile, right? So it's the middle value, right? So anything within 25th percentile and 75th percentile, right? So here's the minimum range, minimum, maximum. You can, check on whatever options you want to. And then you do continue, okay. And over here, I'll share with you the output. So over here, you can see you have the median, you have the mean, median, mode, you have the standard deviations, you have the variances, range, minimum, maximum value, and then percentile. So interquartile range. So percentiles are what? So what you will be reporting in interquartile range is what is the value at 25th percentile and what is the value at this 75th percentile. So you'll be reporting 35 to 55, right? So this is how you're going to report. So you're going to report 47 is your median. That is if your data was not normally distributed. And then in the bracket, you're going to write 35 to 55. And you have to in bracket IQR, right? So this is how you report the medians and the IQRs, right? Now, when we talk about, this is how we report a quantitative variable. But when we talk about the qualitative variable, what to do? So for that, you do not need to worry about normality or anything. It's just reporting frequency and percentages, right? So you go to analyze, you go to descriptive, and you go to frequencies. And over here, what you do, you enter all. So you can just press on shift and just select on all the variables, put them in the variables list, right? And then you have to check on this display frequency table because so frequency tables are displayed for categorical variables, whether they're ordinal or nominal, right? And over here, if you want any charts, so what is charts? I think you will, Dr. maybe Ghulam Murtaza will be talking about, graphs and everything. But charts are, the graphs, right? So, graphs can be also, you can, whatever graphs you want to, it can be a pie chart, it can be a bar chart, histogram, you can, click on these, right? So what we do, we'll go to OK, and over here, you can see that they are different for all the variables. There's a frequency table that is given. So for us, the most important are frequency and percentages, right? So these are the most important that we are going to be reporting. So over here, like it says, males frequency is 4 and percentage is 16, and females frequency is 21 and the percentage is 84. And total number of patients over here are 25, right? And it is coming up to 100%. So there's no missing value. Otherwise, it always gives, if there's some missing value, it always gives well, right? So similarly, socioeconomic status, we can see that a higher, so anyone wants to interpret socioeconomic status, what do you say? Oh, I'm so sorry. I'll go ahead. Okay, so this is the output, right? So over here, this is the gender, as I mentioned earlier. Can anyone interpret that if by looking at, so over here, what I said previously was it frequency and percentages. These are the most important that we have to report. And always remember that whenever you're reporting your results, please do report frequencies and percentages both. Do not report only frequency because this can get, because we don't, if you're just reporting 21 females, right, we do not know the denominator. So that can get very tricky. So always report frequency with percentages, right? So anyone wants to interpret this socioeconomic status? Can anyone tell me which socioeconomic status do you higher, proportion of patients are higher in these categories. So we can see that about 44% of the patients, they belong from a high socioeconomic status. So that's higher, right? When you talk about educational status, can anyone, can anyone interpret the table? Illiterate. Excellent. So 40% of the patients, they are illiterate, right? And when you talk about opinion, so what do you think? What's the opinion? How many, it's on a Likert scale of strongly disagree to agree. What do you say? So a higher percentage is opinion, when we talk about opinion. So strongly agree. And reading newspaper, so I think someone mentioned that a high proportion is about 68%. They are, they read newspaper, right? So this is how we analyze the categorical variables. This is how we report them, right? So I think majorly we have covered both. On the other hand, the other exercise, that is question 2, I will suggest that, it is sort of, your practice for your practice, because we have limited time. So it will be a practice for you. It is a practice exercise for you. So when you go home, just, run the same test that we have run right now. And if you have any queries or any problems, you can always, write to me, nida.zahid@aq.edu, or, we can always, when I'm coming in my other